Alrighty. So if we know this is video 2 of this definition, the limit definition of the derivative. If we know that the slope, the limit of the slopes of the secant lines will give me the slope of the tangent line. In other words, as this point moves closer and closer and closer to the blue point, the slope of the red line gets closer and closer and closer to the slope of the blue line, right? If we know that, then can we set up a formula that'll find that? And the answer is we can set up two formulas. The first formula, some people call the alternate form. I just call it the limit definition because it is the limit definition. And it's going to describe what's going on in this animation here. And what's going on is one point is frozen, right? I'm giving you a specific x value. We're going to take this other x value and it's going to change because it's going to get closer and closer and closer and closer to the one I want. So that's the first form of the limit definition. And so one of them says that to find the slope of the tangent line, which is the derivative, that was from our previous video, to find the derivative at a specific x value, I'm going to call that x value a, because it can be any number. At any value that you want, we're going to take the limit as x approaches a of f of x minus f of a over x minus a. So assuming that we know the equation of the function f, we can set up this formula, which is the average rate of change formula. But what's happening is that x value, that point, if I go back, that point in red, that point in red is getting closer and closer and closer to my value of 3. Well, that's what's happening in this limit. My x is approaching the value that I want. That means my point is getting closer and closer and closer and closer, and the slope of that line is getting closer and closer and closer and approaching the limit, which is the derivative or the slope of the tangent line. So this is going to be one of the two forms of the derivative limit definition. Again, the derivative is the slope of the tangent line. The derivative is an instantaneous rate of change. All right. Once we know that, here's another way we can figure out the derivative, the second formula. And some people, again, feel like this is a little much, but I think you can figure it out. So here, instead of saying the points are getting closer to each other, we say the distance between them is going towards 0. So the distance delta x between them is getting smaller and smaller and approaching 0. Well, as it approaches 0, the 2 points are getting closer to each other. And if they're getting closer to each other, then we're going to get to the tangent line. Okay, so how do I write that? Remember in the previous video, I told you that some people write delta x because that would be the change in x. That would be the distance between them. I like to not use, and some people, also not me, like to use, instead of delta x, we just say h, where h is the distance between the two points. So here they're calling the distance between the 2 points in the horizontal direction delta x, the change in x. I'm going to call it h. And we're going to say f of x plus h minus f of x all over h. If we take the limit of that, that's going to give us the derivative as well. So I come over here and I'm officially going to write it. And I'm going to say f prime at the value that I want equals the limit as h approaches 0 of f of a plus h minus f of a all over h. Let me try to fix this and make it a little bit more legible, a little bit neater. But this is the second formula. But it's telling us the same thing that the first one did. What do they have in common? We're taking a limit. We're taking a limit of a difference quotient. Notice I have a fraction where I'm subtracting the top and the bottom. Notice I have a fraction where I'm subtracting the top and the bottom. The difference is, in the first one, the limit is telling me that the point one point is frozen, we know what the number is. The other one is getting closer and closer to it. They're getting closer and closer to each other. Whereas the second limit says the distance between the 2 points is approaching zero. Well, if the distance between the 2 points approach zero, that means the points are getting closer to each other, and we're getting the same thing. So both of these formulas are what we're going to use to identify what exactly are we trying to find, and applying these formulas is going to help us create the derivative function, which goes beyond just the derivative value. And so we're going to investigate that in the third video.